In this lecture, we will see the schematic diagram of a CMOS buffer. Then we will convert the normal schematic to twisted schematic, and then the process to draw the layout from these two schematic diagrams. So now, this is a CMOS buffer. At first we will see how do we represent a CMOS buffer. Okay. We know buffer means whatever you apply at the input will obtain the same at the output. Input is equal to output. So if I say A is the input, if I give it to an inverter, then the output is A bar. Now what should I do in order to obtain A again? This can be obtained as A bar whole bar, that is equal to A. So here we have to add one more inverter. So the input through two NOT circuits, through two NOT gates, when it passes through it get the same output. Suppose this is input X, you'll get X at the output. So this whole helps in buffer. So now let's see the number of NMOS and PMOS needed. Now when I want to represent a NOT gate, I represent as this. This is my PMOS, this is my NMOS. This is my gate terminal. This is my input, let's say A. This is my VDD, ground, output A bar. This is PMOS, this is NMOS. Source of PMOS, source of NMOS, drain, drain. This is gate and this is gate. Okay. So in the structure of one NOT gate, we have got one PMOS and one NMOS. So in the structure of a buffer, this is for a inverter or not. For a buffer we need two NOT gates, that means two PMOS and two NMOS. Okay, so you can say like this is one NOT gate, so we have to place another NOT gate over here. Now let's move to the schematic part. Now, before going to the schematic, we have to know the truth table. The truth table it is very simple. The truth table of a buffer consists of, suppose this is a buffer circuit. If this is input A, I'll have output Y, which will give same value as A. So we have input A and output Y. So if I have input A, single input, then I'll have two combination, that is 0 and 1. When A is 0, output will be 0. When A is 1, my output will be 1. So this is my truth table of a buffer. We'll see the explanation of this explanation, or you can say the verification of the truth table after we draw the schematic. Okay, now let's see the schematic diagram. The schematic diagram of a CMOS buffer. Okay, so as we know, there are two PMOS and two NMOS, and we have got two inverter. So first design the first inverter. This is the PMOS. This is the PMOS, and then we have the NMOS. Okay, okay, so this is P1, this is N1. This is the source of the PMOS. This is the gate of the PMOS, and this is the drain of the PMOS. So this is the source of the NMOS. This is the gate of the NMOS, and this is the drain. So I know the source of the PMOS is connected to VDD. The source of the NMOS is connected to ground. And the combination or the the two gates are being joined, or they are connected, which gives the input, that is A. Output is obtained from the drain, common drain, that is A bar. So over here you have to place, or you have to draw the schematic of another inverter. This is the PMOS, this is the NMOS, this is P2, N2, this is source of PMOS, this is the gate, this is the drain, source, gate. If we join these two, then this gives the input of the second inverter. This is also connected to VDD. This is also connected to ground, and this is the output, that is A bar whole bar. We can take this output as Y. Y is equal to A bar bar, that is equal to A. The output of the inverter 1 is the input to the inverter 2. So this is inverter 1, this is inverter 2. The output of inverter 1 is the input to the inverter 2. Okay. Okay. So now we'll draw the twisted schematic from this. Now we'll see the twisted schematic. We'll say this is the twisted schematic diagram of a CMOS buffer. The twisted schematic diagram of a CMOS buffer. So we will just twist the inverter 1 and inverter 2. This is inverter 1, okay. Then we have the inverter 2, the PMOS, and the NMOS. So this is P1, N1, this is P2, this is N2. This is the source, drain, source, drain, then this is again the source, source, drain, and the drain terminal. Now we know these are the gate terminals. The gate of PMOS and NMOS are shorted for both the inverter. This forms the input that is A. Okay. Output is obtained from the common drain. This is connected to VDD. This is the output which is given to the input of the second inverter, and the output of the second inverter is obtained from this common drain. This is A bar, this is Y, that is A bar whole bar. We know that the sources of the PMOS are connected to VDD. Okay, and the sources of the NMOS are connected to ground. So this is the twisted schematic diagram of a CMOS buffer. Now we can see the explanation of the truth table from the schematic. We'll see the explanation of the truth table of a CMOS buffer. Okay. The explanation means that we will check for each condition was the output that we obtained, it was correct or not. So for the first case, when input A is equal to 0, when A was equal to 0, then if I see from the twisted schematic, So this was the input A. This was VDD. This was ground. The output, which was the input to the second. This is the final output Y. So when A is equal to 0, then this, okay, we have to give the name to the PMOS. P1, P2, N1 and N2. Okay. As we know that if the input is 0, then the PMOS will turn on and the NMOS will turn off. If it's 1, PMOS will turn off and the NMOS will turn on. So over here, when A is 0, then at the gate of P, that is at GP1, we get 0. At GN1, we get 0. So when NMOS has an input of 0, then it turns off. When PMOS gets 0, then it gets on. So when it turns on, then here P1 will turn on. So when P1 turns on, then it will get short circuited, and when N1 will turn off, it will get open circuited, as if this is P1, this is VDD. Over here there is a open circuit from N1, so this part gets cut off, and at the output we get VDD at output A bar, which acts as input to the second inverter. This is VDD, this is ground, this is output Y. So VDD means 1. This is P2 and N2. So when 1 is applied, at the input, then for 1 we know the PMOS will turn off and NMOS will turn on. So here the PMOS P2 will turn off or gets open circuited, and the N2 NMOS will turn on, that is gets short circuited. So if I say this is the first stage, this is the second stage, then at the third stage we can say that the PMOS 2 is open and NMOS 2 is closed, which is connected to ground, and this is the output Y. So this will cut off and the output will be the low voltage. So Y is equal to, this is the third condition, the third state for the first condition. Y will be equal to ground, or you can say the low voltage or 0. So when A is equal to 0, then output is also equal to 0. So now this is verified from the truth table. Now we will see the second condition, that is when input is when the input A is equal to 1. When A is equal to 1, then let's draw the schematic. This is VDD. This is ground. This is the output, input A, output A bar, which is given to the input to the second inverter, and the obtained output is A bar whole bar equal to A. So when this A is equal to 1, this is P1 N1, P2 N2. When A is equal to 1, then N1 will turn on, P1 will turn off. P1 will turn off, that is gets open circuited. N1 will turn on, that is gets short circuited. This is the first stage. In the second stage, you can see P1 is open, N1 is short circuited, and this is ground. So this is since open, so it gets cut off, and the output obtained A bar will be 0. This is given to the second input, okay. This 0 is given to the second input, where this is P2 and N2. So in the third state, what will happen? When 0 is applied, P2 will turn on. So P2 will turn on, that is gets short circuited. N2 will turn off, that is gets open circuited. Okay. So now P2 will turn on, Okay, N2 will turn off. This is ground VDD. This will be cut, and the obtained output Y will be equal to VDD. Y is equal to VDD, or you can say high voltage or 1. So when A is equal to 1, the obtained output Y is also equal to 1. This is verified. So now you can see that the truth table is correct. Now we will see the layout of a CMOS buffer from the twisted schematic diagram. So this is the layout of a CMOS buffer. That is drawn from the twisted schematic diagram. Okay. So we know that we need 2 PMOS and 2 NMOS. In short, we will draw 2 inverters. So at first we have to draw the PMOS and then the NMOS. In order to draw the PMOS, you have to first draw the P diffusion layer and the N well. So start with N well. So this is the N well. So this is the N well. Then the P diffusion layer. Since there are 2 PMOS, so we'll have 2 P diffusion layer. This is first P diffusion layer. This is the second P diffusion layer. P diffusion, or you can write P diff. Then the after drawing the PMOS, then you have to draw the NMOS. So we need N diffusion layer. There are 2 N diffusion, 2 NMOS, so we need 2 N diffusion layers. So this is the N diffusion layer. So type, you can write N diffusion or N diff. Now after drawing the PMOS and NMOS, then next you have to draw the terminals, the 3 terminals of the corresponding gate. So this is PMOS 1, this is source of PMOS 1, gate, drain, then this is again source, gate and drain. Similarly, that of the NMOS, source, gate, drain, source, gate and drain. So first we will draw the gate. We know in a inverter the gates are connected, gates of the PMOS and NMOS are connected. So and we know this is poly, this is a poly layer. So first we'll complete this inverter. We can do it simultaneously. Similarly, the gate of the second inverter are also connected. Okay. So now this is the input. Let's say this is A. So this is the input A. Now the source of the PMOS is connected to VDD. The source of the NMOS is connected to ground. So since these are two inverters, both the sources are connected to VDD. So this is the VDD. Now the sources of the NMOS, they are connected to ground. This is connected to ground. Now the output is obtained from the drain. So connect the drain of PMOS and NMOS. Okay. So this is a bar. Okay. Now this is given as input to the inverter 2. And this is a metal layer and this is the poly layer. Okay. So there is a overlapping between the metal and the poly layer. So we'll place a poly contact over here. So select the area and have to select the area, this portion in the magic tool and then place a poly contact. Okay. Now this is the input, that is a bar, and the output of the second inverter is obtained from here. which is Y. Okay, you can see this is the final output of the buffer, it is Y. Now this Y is nothing but equals to A. Now, after drawing the layout, you have to place the contacts. Here there is a connection between the P diffusion layer and the metal layer, so we have to place a P diffusion contact. So this is a P diffusion contact, or while writing commands in Magic we write PDC. So since there are two PMOS and we have two terminals in each PMOS, so total we have to place 4 P diffusion contact because there are 4 metal junctions in the P diffusion layer. So over here in the portion you have to place this contact in the portion you want to connect the metal with the P diffusion layer. Similarly over here. Now after placing the P diffusion contact, next here also you have to place a contact in the N diffusion layer in order to make a contact between the N diffusion and the metal layer. So I have to place a N diffusion contact. Or while writing commands you'll write NDC. So similarly over here to place one contact. Even in the NMOS we have got 2 junctions each, so there will be 4. If a junction is not connected or it has been placed in common mode, in common P diffusion and diffusion, then you do not require these contacts. Now after placing the diffusion contacts, next you have to place the substrate contacts. So the substrate contacts are placed in the VDD and ground layer. In the P diffusion side, that is VDD is connected to the PMOS or the P diffusion side. So here you have the N substrate contact is placed here. So just in the metal layer you have to place this N substrate contact. Similarly over here. So this is a N substrate contact or the N-well contact or NWC. Similarly in the ground layer it's in the P diffusion, the N diffusion side, so you have to place a P substrate contact, and you can place as many as you want. Okay, so this is the P substrate contact or the P-well contact or the PWC contact. So this is the layout of a CMOS buffer that is drawn from the twisted schematic diagram. It has got two inverters. This is inverter 1, this portion is inverter 1, and this portion is inverter 2. The input A is given at the gate, output A bar is obtained at the drain. This A bar will act as the input, this output of inverter 1 will act as input to the inverter 2. So this is a metal layer, this is a poly layer. When they come in contact, you have to place a poly contact in order to make connection between these two layers. Then we have the output from the second inverter, that is obtained at the drain, that is Y. The sources of the PMOS connected to VDD, sources of the NMOS connected to ground. All the contacts are placed in substrate and diffusion layer. Now we'll see the layout of a CMOS buffer that is drawn from the normal schematic. Layout of a CMOS buffer drawn from the normal schematic. Diagram. That is the untwisted schematic. So we have to just draw the two inverters first. So this is the anvil. Suppose this is the anvil. Okay. Then we have to draw the P diffusion in order to draw the PMOS. Okay. Now the same area we have to take the N diffusion layer, which is green in color. Okay. Now in order to draw an inverter, you have one PMOS, one NMOS. This is the source, gate, drain, drain, gate, and source. So first we have to connect the gate. Okay, so these two gates are connected, the gate of the PMOS and NMOS. This is the input, that is over here we have taken input as A. Now the source of the PMOS is connected to VDD and source of the NMOS is connected to ground. Okay. the source of the NMOS is connected to ground. I'm not drawing over here the whole metal layer because we know that the same VDD and ground will be drawn in the second inverter. So there we can directly join. So these two drains, the drain of the source, the drain of the PMOS and drain of the NMOS, they are connected in order to get the output. Okay, the output here is A bar. Okay, now next we have to draw the second inverter. This is the N well. This is N well. Then the P diffusion. You can write P diffusion or say P diff. Since this is PMOS, then N diffusion. So this is the N diffusion or say N diff. So this is the source, gate, drain. This is drain, gate and source. This is the PMOS and NMOS. So now the PMOS gate is connected to the gate of the NMOS. This is the poly layer. So the source of the PMOS is connected to VDD. Now these two are connected to VDD, so we can just connect these two. Okay, this is VDD and this is metal 1 or say M1. Similarly with the ground, source of the NMOS is connected to ground. Okay, this is ground. Now the drain of the PMOS is connected with the drain of the NMOS. And this is the final output Y. Now the two inverters, they are drawn separately. Now you have to make a connection between these two, since we know that the output of inverter 1 is the input for the inverter 2. So this is a metal layer. The output of inverter 1 is a metal layer and input of inverter 2 is a poly layer. So you can see there's overlapping between the metal and the poly. So we have to place a contact. It's poly contact. This is a poly contact. Okay. Now the output is Y. This is the output. Input, output. Now you have to place the contacts in the diffusion layers and the substrate. So in order to make a contact between the metal layer and the P diffusion layer, you have to place a P diffusion contact. So this is a P diffusion contact. All while writing commands, you can write PDC. Similarly over here, over here. Now in the N diffusion layer, you have to connect the N diffusion layer with the metal layer. So you have to place a N diffusion contact. So this is a N diffusion contact, or say NDC contact. Similarly over here, these are the N diffusion contacts. So there are 4 P diffusion contact and 4 N diffusion contact. After placing diffusion contact, you have to place the substrate contacts. So the substrate contacts are placed in the VDD layer and the ground layer. In VDD, since this is connected to the P diffusion, and we have to place a N substrate contact, or we otherwise see it as N well contact. So this is N substrate contact or N well contact. Similarly, we have to place over here the P well contact or the P substrate contact, since this is present on the N diffusion side. This is P substrate contact or P well contact. So this is the layout of a CMOS buffer that is drawn from the normal schematic.